Hey kids, in today's episode of Marine Engineering for Kids, we will be discussing this machine right here. Now, does anyone know what this is? I can't hear you. Very good. You got it exactly right. It's a reciprocating two-stage air compressor for marine applications. The purpose of this air compressor is to generate high-pressure air for shipboard applications. High-pressure air is very useful on board a ship. Some of its uses include starting main propulsion engines, supplying air for air-driven tools, also known as pneumatic tools, and even supplying air for the ship's whistle. Additionally, compressed air is used for control air in various instruments and gauges. This air compressor generates the high-pressure air in these cylinders up above. The high-pressure air is then stored in this large blue air receiver where it is held until it is ready to be used. While there are many types of air compressors, we are going to be focusing on reciprocating style today. In order to better understand the way this works, we've developed an extremely advanced technical model for you. Come and join us while we demystify the air compressor.
Glad you guys made it. Here is our technical model of the reciprocating style air compressor. As you can see, there are 5 main components, color-coded with the legend at the bottom. To describe each of these components, let's start with the cylinder. The cylinder is highlighted in green, and it is the housing for the assembly. Inside the cylinder is the piston highlighted in blue. The piston moves up and down in the cylinder to pull air into the system and to compress the air. The crank in purple spins via some type of rotating shaft and drives the system. The connecting rod connects the crank to the piston and turns the rotational motion into reciprocating motion. At the top of the cylinder we have our valves. There are 3 valves which allow air into and out of the cylinder as needed.
Now that we've discussed the components, let's watch a step-by-step simulation. As the crank begins to rotate clockwise, the piston travels downward in the cylinder. This increases the volume of the cylinder, drawing air in through the inlet valve. Air is drawn in until the piston reaches its lowest point in the cylinder, also known as bottom dead center. The inlet valve closes as the piston begins to rise in the cylinder. As the piston rises, the air is compressed until the pressure builds up enough to open the outlet valve, allowing air to escape. Once all of the compressed air leaves the system, the outlet valve closes and the cycle repeats. The last thing to discuss is the center valve, known as the unloader valve. If the air compressor were to shut off halfway through the compression stroke, as shown here, it would be extremely difficult for the piston to continue to rise when the air compressor is restarted. To avoid this issue, the unloader valve is opened when the compressor is shut off to release any partially compressed air. Let's go back to the lab to finish off this great episode.
Hope you guys enjoyed that simulation and now better understand the way a reciprocating style air compressor works. I hope to see you next time on Marine Engineering for Kids.